We're going to start with one of the, what I consider, easier problems. So we're going to take a look at number 4. And this is just going to build our brains back up from the long weekend to how to do these. Okay? Please have your steps to solve equations out in front of you. Have those out. If you've lost them, the anchor chart's in the back of the room. Let me do this. Let me take this so that way if you need to pause the video, you can do that. So there's our anchor chart. You can pause that. That way if you need to, you can kind of write those down. Looking at the ceilings because I'm not allowed to have students in videos. Cool. Okay. There we are. So here's what you're going to do. Same thing as we did last week. I'm going to state the step. You're going to say yes or no after I say 1, 2, 3. You're going to say yes or no, whether we need to do that step. So step 1 says find the balance point. 1, 2, 3.
Yes.
Wow, that was bad. That was garbage even for a Monday. Let's try this again. Find the balance point. 1, 2, 3.
Yes.
Okay. No matter the problem, we always have to find the balance point. It does not matter what the equation looks like. We need to find the balance point. Step 2, distribute if needed. 1, 2, 3.
Yes.
Yes.
Why are you guys crap at this? Try it again. Step 2, distribute if needed. 1, 2, 3.
Yes.
Okay, how do I know that I need to distribute? I should see a lot of hands. Jupiter.
Parentheses.
Yeah, there's something smack dab up against the parentheses. That tells me to distribute. So I'm taking this 11 and I'm multiplying it to only what's in that grouping symbol. So 11 times the x and 11 times the positive 10. That's important. And we rewrite 11x plus 110 equals 132. Step 3 is where it gets a little bit confusing. It says, combine all like terms on the same side. So keep looking at it and just listen to what I'm saying. Combine all like terms on the same side. 1, 2, 3.
Yes.
Ooh. So this is where we get to the confusing part. If I cover this up, can I combine a variable with a constant?
No.
Is there anything on this side to even combine?
No.
So step 3, combining like terms on the same side is a big old no. We can't combine like terms on the same side because there are no like terms on the same side. Step 4, it says combine variables on opposite sides using inverses of addition and subtraction. So we're combining variables on opposite sides. 1, 2, 3.
No.
No. There's an 11x here, but there are no variables over here. So how could I combine an 11x to a variable over here when there is none? Okay. Step 5. Combine constants on opposite sides using inverse operations of addition and subtraction. 1, 2, 3.
Yes.
Yes. Now, the goal is to isolate the x. We want to get the x by itself, which means the only thing on this side should be an x. So do I want to move 110 away from the x or 132 towards the x? Katie? Away. We're using inverses of addition and subtraction. This is addition. So what is the opposite of addition, Zach?
Subtraction.
So we are going to subtract 110 from both sides. 110 minus 110 is 0. That's the additive inverse property, which is perfect. 11x equals 132 minus 110 is 22. Still with me? The last step is isolate the variable. So get the variable by itself using inverse operations of multiplication and division. So our last step is 99% of the time multiplication or division. Go ahead, Katie.
Division.
So what are we going to divide by?
You would divide 22 by 11.
So just this?
Or 11 divided by 11 and then 22 divided by 11.
Yeah, we're going to divide both sides by 11 because 11 divided by 11 is 1. 1x is the same as just x equals 22 divided by 11 is 2. Questions on this? Okay, so that's getting our brain back into it. For some reason, and I don't necessarily agree with Engage New York on this, we're going to go do number 1. So we've just done number 4, which is much easier than number 1. I mean, much easier than number 1. Number 1 is x minus, parenthesis, 9x minus 10, parenthesis, plus 11 equals 12x plus 3, parenthesis, negative 2x plus 1/3. This is as hard of an equation as you're going to get. If you can solve this equation, you can solve any of them. If you can solve this equation, you can solve any of them. So, here we go. I'm going to show you how to break this down because this looks overwhelming. Would you agree? There's a lot going on there. It would look overwhelming. Step 1 never changes. Step 1 we always have to do. Find the balance point. The balance point is always going to be where, Allison? The equal sign. Okay. And that is so important for questions like this. Then step 2 says distribute if needed. Well, right now, I'm overwhelmed by this problem. So I'm going to get a blank piece of paper and cover up half of it. The only reason I do that is because now my brain only sees part of the problem. This looks a little bit more manageable. Than the whole thing. Would you agree? Okay. So do I need to distribute on this half? What am I distributing? McKenna? Is that what's smack dab up against the parentheses?
Could you please dismiss Jessica St. John?
Absolutely. What's directly up against the parentheses? Go ahead.
11.
Not quite. Cody?
The negative sign.
The only thing that's smack dab up against it is this negative sign. So can I distribute a negative? Yeah. What is the number that's associated with that negative? Cody?
1.
Yeah, when it's just a negative, that's really an invisible -1. Everybody with me there? So now let's distribute. Well, wait a minute. There's something out in front of that. What happens to this x?
Wouldn't it go with the -1?
It does not go with the -1.
Would it become like 1x or?
It's already 1x, so where does it go? Do we need to do anything to it? Are we multiplying it? No, so it comes straight down. It just becomes the x. Then we distribute. -1 times +9 is -9x. -1 times -10. Negative times a negative is +10. Have I forgotten anything on that side? What happens to that +11, Stephen? It just comes down because we didn't touch it. Oh, okay. So now we've distributed. Does that we only saw half of it. Does that help a little bit? Sure. So we've distributed on this side. Let's do the same thing on the other side. So I'm going to cover it up. We there? What do we need to distribute on this side? Katie?
The 3.
The what?
The 3.
The what? What kind of 3?
Positive.
Oh, we're distributing the +3. What happens to my 12x that's out in front? Cody?
Bring it down.
Bring it down. +3 times -2x is -6x. +3 times +1/3. Okay, get your calculators. Let's do that. Do 3 times 1 divided by 3. So do 3 times 1 divided by 3. There you go. You're welcome. What do we get? Raise your hands. Zach.
1.
What kind of 1? Positive or negative? Positive 1. Okay. So we've now distributed. Does everybody agree? We're done with that step. Step 3 says combine all like terms on the same side. So now we're still just on this side. What are the like terms on this side? Come on, I should see a couple more hands. Stephen, what do you think?
12x and 6x.
12x and what?
Negative 6x.
12x and negative 6x. When they're on the same side, we read it exactly like it says, 12x minus 6x. So if I have 12x's and we're taking away 6x's, how many x's do I have left over, Cody?
6.
So now I've got 6x. Did I touch the 1 yet? So what do?
Bring it down.
Bring it down. Okay, am I done on that side? Yeah. Okay. So we're still in step 3. Combine all like terms on the same side. What are my like terms on this side? Katie?
X and negative 9x.
X and negative 9x. This is really 1x minus 9x. So if you put 1 minus 9 in your calculator, tell me how many x's we get. Katie?
8.
What?
8x.
Put it in your calculator.
0.
Do 1 minus 9?
Negative 8.
Negative 8x's. Am I done?
No.
Whoa. Why not? I combine those terms. Allison?
There's still positive 10, positive 11.
Oh, so I can combine constants, right? So positive 10 and positive 11 are constants. I can combine constants. Those are like terms. Positive 10 plus positive 11 is positive 21. So now I have an equation that reads negative 8x plus 21 equals 6x plus 1. Okay, so we've done steps 1, 2, and 3. We're on step 4. Step 4 says combine variables on opposite sides using inverses of addition and subtraction. What are my variables on opposite sides? Do I have variables on both sides? Cody?
Negative 8x and 6x.
And 6x, okay. Personally, this is just how I do it. I will always move my smaller variable. Which is the smaller variable? Negative 8 or positive 6? Which one's smaller? Negative 8, positive 6. Stephen? Negative 8. So we're using the inverse of addition and subtraction. What do you think we need to do, Stephen? Am I going to add it or subtract it? Add it. It's already negative. The opposite of negative is adding. Because we want to get rid of it on this side. We want it to become 0. Negative 8 plus 8 is 0 x's. 21 equals. That leaves me 14x. We didn't touch the 1. It comes down. Still with me here? Okay. Step 5. Combine constants on opposite sides using inverse of addition and subtraction. Do I want to move the 21 closer to the x or the 1 farther away from the x? McKenna? 1 farther away. It's a positive 1, so the inverse is? Subtract 1. So now I'm left over with 14 x's equals 20. Our last step states, isolate the variable using inverse operations of multiplication and division. So, do I need to multiply or divide to get x by itself, Zach? It's already 14 times x. Divide. So what am I going to divide by? How do I get x by itself? If it's 14 times x, I need to divide by 14. By 14, good. Okay, 14 divided by 14 is 1x. Put in your calculator. 20 divided by 14, and you should get a decimal. If you give me a decimal on your quiz, I will mark it wrong. Unless the problem starts with a decimal, don't give me a decimal. So from your decimal, press second table, enter. Zach, what do you get?
10/7.
Very good. We get 10/7. That is as hard of a problem as you will get. If you follow the steps, does it break down pretty easily though? as long as you follow the steps, it shouldn't seem all that hard. It's still tough, but it's not all that hard. Okay. Let's try one that I personally think is a little bit easier. You're going to try this one on your own and with your little groups. You can work together. You're going to do number 6. Number 6 is 3 parentheses 2x minus 14. Let me read this down a little bit so I have it. 3 parentheses 2x minus 14 plus x equals 15 minus 9x minus negative 9x minus 5. Go ahead, solve this one on your own. Let me grade your warm-ups. Get those in the grade book. You may move next to somebody if you want to work with them for like 3 or 4 minutes. Okay, if you're watching the video, I'm going to be in front of you for a minute. Enter some scores in here. Okay, I'm seeing a lot of good work to the start when we're distributing. That's a good start. Once you distribute, you remove the parentheses, okay? So once you distribute, you take away the parentheses. Good job, Stephen. Awesome job, man. Let's go about 2 more minutes. Okay, here we go. So, as I walked around, Stephen crushed this. Stephen, normally I'd put you on the spot and make you do the whole thing. I'm not going to do that, but I am proud of you. So, step 1 says, always find the balance point. Did anybody cover up half the problem? Because I didn't see that. So, that's just a strategy that I use sometimes to help me only see a little bit of it to keep my mind working. If you don't want to cover it up, no problems, I don't. So I distribute my 3 to the 2x and my 3 to the negative 14. When we say distribute, that means multiply. So 6x minus 3 times 4 is 2, carry the 1, negative 42 plus x equals. I did not touch the 15, I did not touch the x, they come down. I'm distributing a negative. What am I really distributing? A negative what? Stephen? 1. Negative times a negative is positive. Negative times a negative is positive. That's where I saw my biggest mistakes. Double check your work right now to make sure they're positive. Step 3, combine like terms on the same side. I have 6x's and 1x. 6x plus x is 7x. Negative 42 comes on down. Constants, 15 plus 5 is 20. Negative x, or positive 9x, come on down. Okay, this is where your answer is different from mine. You have 2 options. You can move the 7x, you can move the 9x. I told you my personal way was to always move the smaller variable. This is step 4, combine variables on opposite sides. So this is a positive 7. I subtract 7. I don't like having negative variables. That's why I will always move my smaller variable. That's 0. Negative 42 comes down, equals 20 comes down. 9x minus 7x is positive 2x. Still with me? Step 5, combine constants on opposite sides. Negative 42 and a positive 20. I don't want to bring a negative 42 towards the x. We want things away from the x. So I subtract 20 from both sides. That leaves me with 2x equals negative 62. Last step. We either multiply or divide. This is 2 times x, which means we need to divide. So I'm dividing both by 2. 2 divided by 2 is 1. 1 what? 1x equals negative 31. So I know Stephen got it. I know a couple of you were really close. My question to you now is, do you see where you made your mistake? If you do not, please raise your hand so that I can come around. There's not that many of you in here. Let me take a look at your paper so I can say, hey, right here's where you've had a little bit of a problem. So does everybody see their mistake or understand how we got it? Again, these steps, if you follow step by step by step and you don't try to do it in your own order, we'll get the answer. Questions on this? Okay. So notice how I did lesson 6 first and not lesson 5. So it's not that I disagree with Engage New York, but if you cannot solve an equation, why would I give you word problems where you have to make the equation, then solve the equation? Let's just work about learning how to solve the equation. So I feel pretty good that you guys know how to solve the equation. Let's go back to lesson 5 now to page S, I want to say 17. So we just did lesson 6, now we're back to lesson 5. And there are 2 words that we need to remember from 7th grade. And if you're in my Shine class, we're going to spend some time talking about these as well. What does complementary mean? It talks about complementary angles. And I'm telling you that it's 2 angles that add up to a specific measure. McKenna?
Is it, I don't know how to explain.
Just guess. Complementary angles are 2 angles that add up to what measure? Good guess, 180. Hold that. Allison. It's not 180. Might be less than that.
90.
90. So complementary. 2 angles whose sum is 90 degrees. So complementary are 2 angles that, when added together, equal 90 degrees. So supplementary, McKenna, are two angles whose sum is what? 180 degrees. Okay, so complementary angles, two angles that add up to 90. Supplementary, two angles that add up to 180. These are things that we learned in 7th grade. And the only reason that I remember that these were all in 7th grade is because I taught them, and I remember saying, wow, these are not in the part of a module where I would have expected them. They were at the end of module 1, and I was like, well, this is silly. Like, I remember teaching it. So, we are on page S17. We are taking a look at number 2. Number 2 says, an angle measures 17 more than 3 times a number. Its supplement is 3 more than 7 times the number. What is the measure of each angle in degrees? So, the first question is, how many angles do we have in this problem? That's the first question. How many angles do we have? Cody?
2.
2. We have angle 1 plus angle 2 equaling something. What do angle 1 and angle 2 have to equal? And there's a key word in there that tells me what they're going to have to equal. McKenna?
180.
How do you know it's 180? Supplement. It says supplement, which is supplementary, which means two angles that add up to 180. Everybody with me? Okay. It says an angle measures 17 more than 3 times a number. So I gave you that little sheet that had all those words on it. So the first angle is 17 more than 3 times a number. What do the words more than mean? So go back to where I gave you that sheet that had the word problems. It says word problem keywords. I gave it to you, I want to say on Tuesday of last week, maybe? Katie?
Addition.
Addition. So angle 1 is 17 plus. And then it says 3 times the number. So how am I going to show 3 times the number? So put 17 plus times 3? Oh, plus 3x. That's 3 times the number. There's my first angle. My second angle is here. So does everybody see how I broke that down to find the first angle? Angle 2, its supplement is 3 more than 7 times the number. So what am I going to write for the second angle? It says 3 more than 7 times the angle. What will I write here? Come on, come on, come on. McKenna, what do you think?
3 plus 7x equals 180.
Very good. 3 plus 7x. That's 3 more than 7 times the angle. So, why did I do lesson 6 first? Because now we needed word problems to write the equation. You will absolutely have questions like this on your quiz on December 15th, which is next Tuesday. You will have questions like this on the quiz next Tuesday. But this isn't what it asked me to do. It asks me, what is the measure of each angle? So what I need you to do now is solve this equation. Go. So we need to find x. We need to find the number. So solve this equation. Okay, so now I'm seeing a lot of good answers of x equals 16, which is perfect. So step 1, we find the balance point. Step 2, distribute if needed. There's no parentheses, there's no distributing. Step 3, combine like terms on the same side. Constants combine with constants. Constants are numbers without variables. 17 plus 3 is 20. Then combine your variables on the same side. 3x plus 7x is positive 10x equals 180. Combine variables on opposite sides. Well, we don't have variables on opposite sides. Step 5, combine constants on opposite sides. Subtract 20 from both sides. That leaves me with 10x equals 160. Last step, isolate the variable, divide by 10. X equals 16. Most of us got x equals 16. Give me a thumbs up right in front of you if you got x equals 16. Beautiful. But again, that's not what the question asks. This is why we did lesson 6 before lesson 5. Lesson 5 now says, hey, what's the measure of each angle? Oh, man. So not only did we have to write the equation, not only did we have to solve it, but now we need to say, okay, angle 1 was equal to 17 plus 3x. So angle 1 is 17 plus 3. What do we have for x? What did we just find? 16. So now I've got angle 1 equals 17 plus 3 times 6 is 8, carry the 1. So now I got angle 1 equals 65 degrees. I found one angle. You have to go back and substitute in. Whew. How are we going to find angle 2? Go ahead.
You can just do 180
I could do 180 minus 65 if we remembered supplementary. What else could we do? What else could we do? What's angle 2? What did we say angle 2 was? McKenna?
Positive 3 plus positive 7x.
Yeah, angle 2 is 3 plus 7x. So angle 2 equals, we're substituting in what we found for x. 3 plus 7 times 16. That gives me angle 2 equals 3 plus 112. Which gives me angle, what am I doing? Angle 2 equals 115 degrees. Questions there? So, we've only done one word problem. You will be seeing some of these word problems as warm-ups. So, on Wednesday, expect one of these as a warm-up directly from this problem set. Okay, I've already got one that I think will be a nice easy one, but it will be there. We're going to still go over equations. You have lessons 7 and 8 that you need to watch. 7 is a review of what we did today in lesson 6, but you have 2 new options. Sometimes you can have x equals 16. Sometimes you're not going to get a solution. Sometimes you'll always get a solution that's every number you plug in. In lesson 8 is proportions. Didn't we solve proportions last module when we were doing scale factor? We had to cross multiply. That's what lesson 8 is. It's harder versions of cross multiplication. Okay, so your homework is to watch lessons 7 and lessons 8.